In November 2024, an extraordinary underwater eruption began at the colossal AIC Mount near the Mariana Trench, Earth's deepest point. The eruption created discolored water plumes and possibly floating pumice across the ocean surface. The northern Mariana Island Volcano Observatory quickly elevated the volcano alert level to advisory and the aviation color code to yellow, signifying heightened activity with potential implications for the region. While the immediate risks are minimal due to its remote location, the event underscores the geological forces at work in one of the most tectonically active areas on the planet. AIC Mount is a massive submarine volcano rising from the depths about 18 kilometers southeast of Farallón de Pájaros in the northern Mariana Islands. Its summit lies approximately 75 meters below the ocean surface. It is part of the dynamic Mariana Volcanic Arc, a chain of islands and underwater volcanoes stretching across the western Pacific Ocean. This region's geological activity is fueled by the subduction of the Pacific Plate beneath the Philippine Sea Plate, where intense heat and pressure cause the release of water and volatiles from the descending plate. These substances interact with the mantle above, lowering its melting point and generating magma that rises to form volcanic features such as AIC Mount. This eruption, which began in August 2024, has gained attention due to its scale and implications. Advanced satellite imagery and remote hydrophone systems have been employed to monitor the activity. Hydrophones are designed to detect underwater sound waves generated by volcanic eruptions, but so far they have not recorded significant signals. Interestingly, eruptions at undersea volcanoes like AIC Mount often produce substantial plumes without strong acoustic signals, making visual and satellite observations critical. Despite these technological advances, monitoring underwater volcanoes remains challenging due to their inaccessibility and the absence of local seismic stations. The ongoing activity at AIC Mount highlights the unique difficulties of studying underwater volcanic eruptions. Unlike land-based volcanoes, which benefit from extensive seismic networks, submarine volcanoes rely heavily on remote sensing technologies to detect changes in water coloration, surface temperature anomalies, and the presence of floating pumice, or gas bubbles. These indicators help scientists monitor eruptions and assess potential hazards. While AIC Mount is located far from human populations, its activity poses risks to maritime navigation. Floating volcanic debris can damage vessels or disrupt operations, necessitating caution from mariners in the vicinity. AIC Mount's history demonstrates the transformative nature of underwater volcanic activity. Past eruptions, such as those in 1979 and 2001, have significantly altered its structure. In 1979, a fishing crew reported vibrations near the summit, followed by sulfur water upwelling. In 2001, an explosive eruption was detected through seismic activity recorded hundreds of kilometers away, underscoring the importance of remote monitoring systems. Another major eruption occurred in 2014, creating a new summit crater and a landslide chute on the seamount's southeast flank, further reshaping its structure. More recently, AIC Mount exhibited volcanic activity between October 2022 and May 2023, followed by another phase from December 2023 to April 2024. These events reaffirm its status as an active geological hotspot and emphasize the need for continued observation. The seamount's geological setting, involving the interaction of subduction processes and back-arc basin spreading, contributes to its frequent eruptions. This interplay results in the formation of magma, which repeatedly erupts onto the seafloor, building layers of rock that gradually form the seamount. Despite its height, AIC Mount has not yet breached the ocean surface to become an island, but persistent activity could eventually push it above water. The seamount's formation is shaped by volcanic eruptions and tectonic forces. Its summit features a crater formed by explosive eruptions, and its flanks bear evidence of landslides caused by the instability of volcanic material and tectonic movements. These structural changes are common in underwater volcanoes, where the steep slopes created by rapid volcanic material accumulation can become unstable. Additionally, the nearby back-arc basin contributes to AIC Mount's formation by supplying magma through seafloor spreading. Despite its remote location, AIC Mount's activity provides valuable insight into submarine volcanism and the geological dynamics of subduction zones. These eruptions offer a window into the processes that shape the Earth's crust and underline the importance of understanding such phenomena to mitigate potential hazards. While AIC Mount's eruptions are unlikely to directly trigger other Volcanic events in the Pacific Ring of Fire, the possibility of indirect interactions cannot be entirely ruled out. Large-scale eruptions or associated tectonic events, such as significant earthquakes, could alter regional stress fields in the Earth's crust, potentially affecting nearby tectonic systems. However, such interactions are generally limited to geographically close regions and are rare. Dynamic triggering, a phenomenon where seismic waves from a powerful eruption or earthquake disturb other volcanic systems, has been observed in certain cases. For this to occur, the affected magma chamber must already be under considerable pressure and close to erupting. This makes dynamic triggering a contributing factor rather than a direct cause of eruptions in distant volcanic systems. When comparing AIC Mount to other notable underwater volcanoes such as Hunga Tonga Hunga Ha'apai, significant differences emerge in their eruption styles, environmental impacts, and geological characteristics. Both volcanoes are part of the Pacific Ocean's dynamic volcanic landscape, but their unique features and histories underscore the diversity of submarine volcanism. AIC Mount, with its frequent activity and transformative eruptions, highlights the continuous evolution of Earth's underwater landscapes, offering opportunities to study the immense geological forces shaping our planet. The eruption of AIC Mount near the Mariana Trench in November 2024 is a powerful reminder of the vast and largely unexplored geological forces at work beneath the ocean surface. This submarine volcano, part of the Mariana Volcanic Arc, continues to captivate scientists with dynamic activity and transformative power. The eruption, which began in August, has generated plumes of discolored water and potentially floating pumice, signaling ongoing volcanic processes that are challenging to monitor and understand fully. The significance of AIC Mount lies not just in its current activity, but also in its geological setting. Located in one of the world's most tectonically active zones, the Mariana Trench marks the boundary where the Pacific Plate subducts beneath the Philippine Sea Plate. This subduction process drives the formation of magma deep within the mantle, fueling the volcanic activity that gives rise to features like AIC Mount. Over millions of years, successive eruptions have built this undersea giant, which now stands just 75 meters below the ocean surface. While it has not yet breached the surface to form an island, its persistent activity suggests this could happen in the future. One of the most striking aspects of AIC Mount is the difficulty of studying such underwater phenomena. Unlike terrestrial volcanoes, which are closely monitored with seismic networks and ground-based observations, submarine volcanoes are often located in remote, inaccessible areas. Scientists rely heavily on satellite imagery, remote sensing, and hydroacoustic sensors to monitor these features. However, these tools have limitations. For instance, hydrophones, which detect underwater sound waves generated by eruptions, have not recorded significant signals from AIC Mount. This highlights a unique challenge. Undersea volcanic activity can produce substantial plumes and other visual evidence without generating strong acoustic data. The challenges of monitoring AIC Mount underscore the importance of technological advancements in studying submarine volcanoes. Satellite imagery, which can detect changes in water coloration, temperature anomalies, and surface disturbances, has been crucial in tracking the ongoing eruption. These observations are complemented by hydroacoustic sensors that detect subtle underwater sound waves, providing additional insights into the volcano's activity. Together, these tools allow researchers to piece together a picture of what is happening beneath the ocean surface, despite the absence of local seismic stations or direct observation. AIC Mount's history offers a glimpse into the transformative power of submarine eruptions. Past events, such as those in 1979, 2001, and 2014, have significantly altered the volcano's structure. For example, the 2014 eruption created a new summit crater and triggered a landslide on the seamount's southeast flank. These events illustrate how underwater volcanic activity can reshape the seafloor dramatically, building new features while eroding others. The most recent eruptions between 2022 and 2024 reaffirm AIC Mount's status as a geologically active hotspot with ongoing activity that continues to shape its structure. Despite its remoteness, AIC Mount's activity has implications for human activities in the region. Floating pumice and volcanic debris pose hazards to maritime navigation, potentially damaging vessels or disrupting operations. Mariners operating near the seamount are advised to exercise caution, underscoring the broader importance of monitoring. Submarine volcanic activity to mitigate potential risks.